HTTP00 request, right? That's an unsupported protocol that doesn't exist as a version number. So if we look at that, what's actually happening? Well, the CIA website is replying to that. Okay, and it's sending some data back. It turns out that even if you put 00 here, you can actually get some data back. So there's all these different fields in header requests, all these different fields in actual parameters which are not related to a username and a password in a post field, which are just susceptible to potential vulnerabilities. But because we don't have our hands on a decent API to fuzz them, quite often they get neglected. Again, this is not a vulnerability, but it could be a potential entry point. So, and just to prove the point here, if I do that, delete this. So the last request here is that, and so the CIA website officially supports HTTP 00. Again, nothing major, but it hints towards where we're going with this. Okay, so that's the motivation behind why we've put all this work to uncover all the different APIs, etc. By the way, if there are any questions, feel free to stop me and interrupt. Okay, so if we look at the implementation of the actual fuzzers, well, the payloads are in a file, and the file is distributed with the distribution of any new release, and basically in this file you can define your own payloads, etc. But you have a fuzzer that can belong to many categories, so it can be used from many different angles. For example, HTML encoding validation routines quite often have to be checked for both cross-site scripting and SQL injection because they could be different. And each fuzzer has to be unique, very basic. It has to fall in a category, have an ID, etc., and carries its own payloads. The final thing is that each fuzzer has to be one of the two. So we either go through replacing with the payloads, or we generate an alphabet concatenating and enumerating the different variables here. Okay, so if we look at the actual file, and this is what it looks like. So to give you the basic example, let's say that you found a prompt, and I think this is also in the write-up. Let's say that you found a prompt that only accepts DNA characters. Okay, so how do we iterate through all those in the minimum amount of code using something standard as a library? So if I just bring that up. Okay, so by adding these 4 lines here, 5 lines, you can see that we've just implemented the capability to go and select any one of, let's say, these statements and just iterate through what we specify in the alphabet. So this, again, is an enumeration exercise, so the first probably field is going to be ATC G, and then obviously we're going to iterate through that basic. Okay, so going back to the slides, so we've implemented a core fuzzing engine, okay, but how do we actually overcome the problem that we have with all the protocol APIs? Again, I've spent some time on this, recursive versus replacive fuzzers. So what are the problems that we have? Well, if you use anything other than sockets, you don't have control of everything that's on the wire. If you use sockets, then you don't know when what's coming in actually finishes and if it obeys a particular specification of a protocol. Now, because this is targeting HTTP, well, it has HTTP 1.1 has a bit of state, but not too much. So we're targeting a very small section of a protocol and seeing it from a higher layer, the layer of a socket. So if we were, let's say that today you started writing a fuzzer and you decided to rewrite the sockets to implement HTTP for fuzzing, what results would you need to overcome? Well, you'd have to implement the post content length rewrite. So every time you're posting something, if the length of the post changes, i.e. you've selected a parameter and you're fuzzing that parameter, then the content length of that changes. So you've got to take that into account, otherwise the request doesn't make it to the web server. And also, you've got to look at things like chunked encoding, where you get things back from the server, but you get them in little blocks or chunks. So again, this is much, much easier to do and actually implement through sockets. Now, going back to how can we use all this, and I'll be coming to this slide as well. Okay, it's all very good that we've implemented a jar file, but how can we give this to other people to use and implement their own fuzzers? So how do we make a fuzzing tool a potential fuzzing framework, something that other people can use? Well, people are not going to be interested in the UI interfaces that you've added and the color coding, nor are they going to be interested, especially if they're penetration testers, on how you deal with sockets, because they won't trust it. They will want to do it themselves. So it's worth actually giving them a core API that uses all the payloads which are in a file and allows you to group them in meaningful ways. So going back to actually scripting, and I'll spend a bit more time on this. Well, okay, this is a basic example, and again, you can do this in many ways. I've picked a hex fuzzer because it's straightforward. So let's say that you wanted to generate all the numbers in hexadecimal, 5-digit numbers from 0, 0, 0, 0 to all the Fs. Well, okay, there are many ways to do it, and this is a straightforward example, but what actually JBROFUZZ does is it goes and implements the fuzzer class as an iterator. So you don't have to worry about where you are in your fuzzing. You just request a next element, and if that exists, you just access it. And you don't need to worry about the actual details which are there. So that's quite handy when it comes to more complicated things like URL, base 32 encodings and base 64 encodings, etc. Okay, so 1.1 versions later, so the version numbers obviously go up in increments of minor versions, 0.1 being the first one, 1 the last. There are 47 classes in 13 packages, a really small project, just 13,000 lines of code. And some key conclusions: if you're going to do something in the name of fuzzing, make sure you do it well. So implement it in a way that it doesn't break. Why? Because whoever uses it will actually break that API. Tell the user what you're putting on the wire. Especially in the security domain, it's very often that I come across tools and I don't know when I hit start, select, enter, what's happening unless I have a Wireshark session in the background capturing all the results. That's very important. Don't obey the protocol that you're fuzzing. There's no reason to obey the protocol that you're fuzzing. All you're interested is to see what responses it gives back. Whether or not the data is encoded in the right language, well, yes, okay, it does make a difference. And ideally, you would want that information. But for someone that knows what they're after in terms of the payloads that they're putting on the wire, encoding of the data coming back shouldn't be a problem. And put some trust in the core to generate these payloads. So if we go back to the actual user interface,